A multimeter is an instrument designed to measure two or more electrical quantities. All multimeters measure voltage and resistance, and most will measure current as well. These three measurements are the most common, but many multimeters can do much more. They may be able to measure other quantities, like capacitance or temperature, have more sophisticated displays, or include special measurement and recording functions. Early multimeters displayed measurements with a needle on a dial, known as an analog meter. They were designed and used with little concern over damaging a circuit due to their loading impedance. But along with the introduction of microelectronic circuits came the need for digital multimeters. Their high impedance wouldn't load the circuit or components under test. The digital multimeter, also called a DMM, soon became known simply as a multimeter. There are many different multimeter models, and some may look intimidating, but don't be alarmed. They all share common basic functions, and some have more advanced functions that we'll learn about later. You should know that different multimeter models may be required depending on the measurement task. For example, an entry-level maintenance technician may need a multimeter with only basic functions. On the other hand, a technician who troubleshoots or works with control signals may need a more complex instrument. We'll use a common model, the one in the middle, as our example throughout this course. Your multimeter may look a little different, but all of this information should still apply. The first thing to learn about a multimeter is how to configure it for a certain type of measurement. This is done with a rotary function selector switch in the middle of the multimeter. The symbols around the switch represent the measurement functions. Most are internationally accepted symbols, which multimeter manufacturers treat in the same way. However, some symbols may be arranged or combined differently on different multimeters. Most symbols represent the unit abbreviation for what's being measured. For instance, V is for volts, the unit for voltage. Voltage is considered the most common quantity you'll measure, used to detect the presence and level of electrical pressure in the circuit. The multimeter may also have MV for millivolts, typically used with electronics or control signals, or for some multimeter accessories, which we'll talk about later. A is for amperes, or simply amps, the unit for current. Current is typically measured to verify the health of a load. It's relatively common to include an MA for milliamperes and sometimes even a UA for microamperes. These functions are used when measuring very small amounts of current. The graphic symbols above the volt or amp symbols identify if the function is direct or alternating, current or voltage. The parallel, straight, and interrupted lines represent current that's traveling only in one direction, direct current. For alternating current, a curved line is used to represent a simple sine wave. The arrangement and location of functions may vary from meter to meter. Some multimeters are made for measuring very small voltages and currents, which include millivolt and milliamp functions, or have dedicated test functions, resulting in various combinations of letters and symbols around the instrument. Some multimeters combine the AC-DC symbols if the meter is designed to automatically configure the measurement of AC or DC for you. The symbol for ohms is the Greek letter omega, indicating resistance. Resistance measurements tell us about the state of a circuit path or the value of a component. The same switch position typically includes the continuity symbol, which looks like a series of sound waves because the multimeter provides audible feedback when continuity is detected. The beep is especially helpful because you can hear the result without looking at the multimeter display. The measurement of low resistance indicates continuity, which means that current can easily flow through that path. Some symbols on this multimeter are in a different color to differentiate between a primary and secondary function, used to manage the limited space around the switch by placing two measurement functions together. The primary function is the default because it's deemed more common and is shown in white on this instrument. The secondary functions are shown in a contrasting color and are accessed by pressing a secondary function button, usually in the same contrasting color. To return to the primary functions, the secondary function button is pressed again. For example, to measure capacitance, the selector switch is rotated to the position marked by the capacitor symbol. Since the primary default function is the resistance and continuity measurement, simply press the secondary function button to change to capacitance. Some symbols on this multimeter are in a different color to differentiate between a primary and secondary function, used to manage the limited space around the switch by placing two measurement functions together. The primary function is the default because it's deemed more common and is shown in white on this instrument. The secondary functions are shown in a contrasting color and are accessed by pressing a secondary function button, usually in the same contrasting color. To return to the primary functions, the secondary function button is pressed again. For example, to measure capacitance, the selector switch is rotated to the position marked by the capacitor symbol. Since the primary default function is the resistance and continuity measurement, simply press the secondary function button to change to capacitance.